Oh, how are you?
Hello, how are you? I'm good. You?
I'm great.
Yeah, so have you gone to the previous session?
Yes, I was watching the video.
Yeah, so
Uh,
do you have any issues or queries regarding the previous session?
let me try to get in. Okay, yeah. Okay, now you can tell me now.
Yeah, so have you gone, means like any query do you have regarding the previous session?
No, it's everything is clear. Just getting ready to learn from the other part, the console.
Yeah, so little more, much part is covered in the previous section, like the basic theoretical portion. Now let's start with some basic terms of SQS only. Okay, then today we will complete the SQS theoretical part, okay, as well as the practical demo of it, like how you can use it and how you can send and receive the message using SQS, right?
Okay.
Okay, so yeah, so
Uh,
the new, yes, anything?
are you recording? Are you gonna do the same thing as?
Yeah, I'm recording and I'll send you the link inside.
Okay, thank you.
Yeah, okay. So see, the today's topic that I have that you must know regarding SQS is retention period. Like previously, we just to revise a summary about the previous session, what we have gone through. Like we have discussed what is SQS, right? What are the important features of SQS, right? Then we have gone through uh, basic things like the basic introduction of billing sessions, how billing can be made in
Uh-huh.
SQS, right? And the cases in which we uses AWS SQS service, right? Then we have gone through two types of SQS that happens that are available inside AWS SQS. One was standard,
Mm-hmm.
one was standard queue, right? Another was
Before. Oh.
first in, first out, right?
Mm-hmm.
Then we have gone through other topic called as visibility time. Like I have just given you an explanation. We have not covered the theoretical part of it, but I have just explained you in the end. Yeah. So anything else we have gone through? Am I missing something?
Visibility time. I think that's all.
Yeah. These were the basic things that we have covered in the previous section. So today we will start with a very fresh topic called as pooling. Okay. How SQS deal with pooling. What is pooling in, you can say, SQS? So basically, pooling is of two types, right? First is short pooling, right? And the another type of pooling is long pooling. Getting it?
Mm-hmm.
So see, pooling is like pulling, if you are pulling something, basically you can understand pooling by the simple English word called pulling. Okay, like for example, if you want to understand, see, this is a server. You can say server 1. Okay, this is its S3 bucket from which they store the message, right?
Uh-huh.
This is the queue we have. SQS queue we are having, inside which multiple messages are given, and this is server 2. Okay, so when any server is continuously checking on the queue and this selects a message and try to get it into the server, this process is known as pooling. Right? Similarly, if this server is trying to access this message, then the process of server to access the message from the queue, right? From the queue, they want a message. So the process of taking a message from the queue is known as pooling. Getting it? Okay. So now if we come to short pooling and long pooling. Okay. So when the concept of pooling comes in, we discuss a very basic example. Okay. Like if you are dealing with a tug of war rope. Okay. There is one person here and the another person here. You both are trying to pull it in your own direction. Right? Say this person is very much strong. This person is also strong.
Okay.
Both the persons are strong. But what difference they have? It isn't technical. What technical method they are using? They are different. Say one is using short pulling.
Okay.
And another is trying the method of long pulling. So if it is trying to access it using short pulling, it will not wait for the first one to start pulling this object. It will just focuses on this object and try to pull it. But what the difference comes in with the first one, it will check that at what force this second person is trying to pull this object towards him or her. Okay. Then according to the force applied by it, they will start pulling. The first one will start pulling. So it is waiting for the second one technique so that later on they can apply or check the strength of the second one and access the object. Okay. So if we go in the very much basics of short pulling. Okay. So when there is a server and this is a queue, right? So this server is continuously checking this queue. Okay, is there any message in the queue? Is there any message in the queue? Okay, it will continuously check this queue without waiting and it will return the output just without waiting. It will go and check the queue. It will go and check the queue that is there any message and return it to a server that there is no message. Right? Then again it will go to the queue. Is there any message in the queue and it will return and say no message. Sometimes it's a case that inside a queue the message is just has to be an arrival, but before that only, without waiting for the message to come inside the queue, server has already checked the queue and returned the message like no message. So it is doing it quickly without the message. It is doing it quickly, going and checking from server, going to the queue, and without waiting for any time, says for 0 second it waits and it returns the output to the server that is there any message in the queue or no message in the queue. So here the waiting time it is taking is 0 seconds. But when we talk about long pulling, the concept is very much different. In long pulling, what it does, This is a server and this is a queue. Okay, so when we apply long polling, it will go to the server and it will wait for say 1 second, 2 second. It depends on our setting, what time we are providing to it. Okay, and then it will go to the server and say either there is a message or no message. Getting it? So whenever in any of the situation the waiting time is 0, we will say that it is a type of short polling, and when it is greater than 0, right, then we will say it's a long polling.
So I have a question. So
Yeah.
so the server take is for short polling. For short polling, the server one, the first one that you explained, is can see the message quickly than long polling.
Yeah,
Means,
it is not waiting. It's not waiting for the message to come in, or it's not waiting for any of the second. It's like it's like this. There's a stone, and here's a person. Okay, there are two person. You can understand like this. This person goes and touches the stone and comes back without waiting for any of the time limit. Okay, it just goes and touches the stone and come back. But when it comes to the second person, it goes to the stone, wait for some time, and then come. So this is known as short pulling, and this is known as long pulling.
So in terms of pricing, there is a difference?
No, yes, and just I'm coming to all those points. I'm just giving you the basic introduction, like you understand the concept, then we will discuss about everything, like how it works, all the theoretical points.
Okay, got it.
So you're getting it the concept, like in short polling, they just go and without waiting for any time limit for the queue, they just come back in short polling. But in long polling, what it happens, it will go and wait for some time by observing the queue, and then it will give the result to the server. The main concept of difference is wait.
Okay, thank you. I got it now.
So let's talk some theoretical parts of short polling. So in short polling, when we send a request, is returned immediately. Even if the queue is empty. You're getting this point? You're getting this point that I have written on the screen? That
yes.
A request, it will return immediately even if the queue is empty. They will not wait for the message to come in. Okay, they will directly go and it will immediately comes back. Means if you from a server, okay, to the queue, if we talk, so from a server it is sending request that go and check if there is any message in the queue. Okay, but without waiting, it will just go check the queue and it will return. So that return is very much immediate, irrespective that the queue is empty. They don't care if the queue is empty or not. Is there any message or not? Okay?
Oh, okay, got it.
Now, what is the disadvantage of this short polling? As you can understand, the biggest advantage is request gets wasted. How request is getting wasted? Like, see, this is a server.
It's not making sure that.
Yeah, this is a server and this is a queue. It is sending a request and it is returning. It is again sending a request. it is again returning. Okay, sometimes what happens, like it is sending a request, okay, and here from here the message is just about to come, then also it will return to the server and say there is no message in the queue. So what is happening, multiple requests are getting wasted because the main aim is to check if the message is there. So receiving the message is the important thing, that is there any message, we have to check this message. No, why this server is sending the request to the queue, to check whether there is a message. Then I will once I will sense that there is a message in the queue, then I will pull it, right? But because it is very much fast, they are not waiting for the message or for the queue. So multiple requests are getting wasted because they are empty, because they are not carrying any of the message. Getting it?
Okay, I got it.
Any question?
If I were the server, I prefer not to use short pooling.
See what's the advantage. Just let me just finish this topic, okay? Because
Okay.
When we apply any concept, okay,
Uh-huh.
there's a application which is very much dependent on that service. You can't say that this short pulling is a waste, because some application required so much that long pulling is not able to do that.
Okay.
Right? Both of them goes according to the application we are designing, right? So next point we can say about short pulling. So till now I have explained you that it does not wait for the message to appear. Yeah, this is clear. This point is very much clear now.
Uh-huh. Yes.
Now
wait for the message to appear.
Yeah. So see, if you try to understand this, that there's a message. Okay. Or you can say there is a queue inside which there are multiple messages. Message 1, message 2, message 3, message 4, message 5. And there is server 1, server 2, and say there are n servers. Multiple servers are there, which are accessing this queue, which are monitoring this queue, right? So what happens in short pulling? This queue, this SQS queue will randomly select some of the servers. Okay, so out of these n servers, what SQS will do, it will randomly select the random servers which can do short pulling on it. Like again and again, going and checking for the message, sending the request, receiving the request, sending the request, receive the request. So it is a random process in which servers are selected. Like if you try to imagine, there's a big, huge data centers, like say Amazon data centers, right? Data center is a collection of servers, multiple servers they have. Okay. Okay, multiple servers are there. And if they are monitoring a single queue, we don't know which all the queues are sending requests to this SQS queue. That is, if any message occurs in this SQS queue, so I can detect it. Every server is detecting a message inside it. But what SQNS queue did, it will randomly select which server they have to send the notification back, right? So in the case of short pulling, this occurs that we have to select random servers because there are multiple requests that can be made. right? I told
Mm-hmm.
the number was 256, I think. So 256 KB requests can be made, right, from one
Okay.
server. So there are many requests that can be made. So they randomly select some of the servers so that they can justify the message. Okay. Uh, okay. See, one disadvantage of short pooling is that because we are making multiple requests, okay, multiple requests, we don't know how many requests we will get the result. So if there are multiple requests, the cost will be high, right?
Hmm.
This is very much sensible to make.
Okay.
Okay.
If the cost is high.
Yeah, because
Like,
you're making multiple requests. See, there's a situation in SQS queue that there only one message has to come, right?
okay.
And this server is applied short pulling. Okay, so it is continuously going and checking for the message, but it is not able to get the message yet. So for one single message, they are wasting hundreds of requests, right? So when instead of one request, in the cost of one request, we are applying 100 requests. So automatically price of 100 requests is more. So there's a loss of money in case of multiple requests because they are getting wasted. When our work can be done in one request, but we are wasting 100 requests. So automatically cost will increase. Getting it?
Mm-hmm. So what will be the advantage?
What will be the?
The advantage.
Yeah. Just
Sure.
see, first of all, wait time for short pulling is always 0 second. Okay.
Okay.
If it is more, then it will come to long pulling.
But the chances of getting the message
Chances of getting?
of getting like is that the short pooling has less chances to get a message.
Yeah. See,
Maybe because of the wait time is
where we usually apply short pulling. See, there's a process. This is process 1, process 2, process 3, process 4, and process 5. Right? This is a set of application that they can't be run individually. Process 1 needs process 2 to get implemented. Process 2 needs process 3 to get implemented. And process 3 requires process 4 to get implemented. And process 4 needs process 5 to get implemented. If any one of them is missing, the operation will fail. Right? So when we send this process 1 as message 1 to the queue, right? So here
mm-hmm.
process 1, and our server has to detect this process 1 and take it in the S3 bucket, right? But if we apply here any waiting time, okay, if we apply any waiting time, this process 1 is now in the S3 bucket, right? Now this P2 will go into this, right? If we apply any of the waiting time, then it will take time that this P2 will also go to this S3 bucket. And as we know that if we want to implement P1, we require P2 also. Okay, see, like there's an object. I think you must have played this game. See, this is the object. Okay, this is one part, second part, third part, fourth part, fifth part, sixth, seventh. Like these are the parts of the game. Okay,
Mm-hmm.
this is a complete. You can see this is a complete game. Without first part, second will not run. Without second, third will not run. Fourth will not run. Fifth will not run. So we need a complete set to run this game. So in the queue, this first is being sent. Okay, and this is the server. So server will detect and it will send it to the S3 bucket. But if the server, then first is gone, then second will come. But if the server is not continuously monitoring this queue and has wait time more than 0, then it will take time to detect the second part, right? So this, and the similarly third part will come. So if there is a time which is more than, say, the waiting time we have kept as 5, waiting time we have kept as 6. So here in the S3 bucket, 1 is useless because it can't do anything without the second part. Second part can't do anything with the third part. So that's why short pullings comes in when you have a segments of process, pieces of
Okay.
process with you, and you have to continuously check if first piece is there. Then when we have received first piece, then we need a second piece. So when we need no waiting time, when we need waiting time as 0, second in any of the process, like in segmentation process of any of the industrial use, you can check. Okay, there we use short pulling. Getting it?
Okay,
See,
got it.
like if you do you know DevOps?
Demos?
DevOps.
No, I don't.
You know,
I know it's you know, I don't
development and
know.
operation.
I,
This part, you know, development and operation.
I just am familiar with the word development of operation and
See, what
development.
happens usually in any of the automation part? Okay, just imagine there's an industry, right? Where you want to build a bike. Okay,
Mhm.
so one tire of the bike is here, motor of the bike is here, handle of the bike is here, and any other part, what you say, second wheel is here. So they are in several different parts. Say
Okay,
first part, second part, third part, fourth part, right?
got it.
So now if you want to make a complete bike, you need them one after the another, right? Then only you
Mhm.
will be able to complete a bike, right? So where here you don't need any waiting time. You want this process, like if this machine is asking that I want the first part, so you will just send the first part, then the second part, then the third part. Here you
Okay,
to wait. Here the waiting time is 0. So in such process, short pulling.
got it. Oh, okay, okay, that's very clear.
Actually, this concept of short pulling and long pulling is about messages, because this is completely a message system we are designing. But I think so you were not able to understand using those things about message. That's why I have used this hypothetical example. Like different parts of message are given. Say this is like written HIGOOD, morning, right? This is a complete message. If you want to send it to someone, right? Like, let me just clean this, let me explain you. See, this is hi, screen, you can say. Okay. Now, if you want to completely send this message to someone, say this is in a queue format. This is inside a queue. Right? This is first message, this is second message, this is third message, fourth message, fifth message, sixth message, seventh message, eighth message. Okay. So if you send this hi to the server, and this they store in their S3 bucket SH. It doesn't make
Mhm.
sense. What is H? So if a person is sending a complete message, continuously they want to send all the parts, all the messages in a continuity form. Then only this complete message will make a sense. And here the complete message will be formed and then the next process can execute. Right? So in such cases,
Okay.
getting it?
Yeah, so there is no waiting time.
Yes, in any of the cases, like in automation processes. One process in automation process is very much useful, right? So in cases where wait time between the server and the queue, we need as waiting time as 0, we use short pulling. The easiest way you can put it. This is clear?
Okay. Perfect. Sure.
Okay.
Okay.
Move
I'm
to
trying to
long.
imagine like in my mind how that works. Well, when I get to the console, I might see it like, message you back and forward. I mean, do I see, am I be able to see the process with my own eyes through the console? Short pulling, short pulling versus long pulling.
Yeah, I'm showing you like, see, this is an Amazon platform. They will give you their option like what delay time you want. They will just ask you there. If you put delay time at 0 second, that means it is short pulling.
Oh, okay,
If
got it.
you put more than that, then it is long pulling. But here I'm trying to make you understand what behind this scene is going on, what they mean by delay time. Okay?
Got it.
See, there are multiple concepts. Let them join together. Then, when we'll see the implementation part, you will be able to understand why we are doing this and why we are using this function. Okay? Just
Okay.
for the class to just unfold a little bit more. So, long pulling. See, it is the most preferred one. Okay? Rather than using short pulling, people usually prefer long pulling. Okay? And what it does, see, first of all, it waits, as I told you. When the server is there and the queue is there, right? So when server interacts with the queue, it will wait to check if any message is coming in the queue or not coming in the queue, right? And then it will, once the request is sent from the server to the queue, it will wait here to check if any new message is coming. Then it will go and inform the server that there is a message or no message in the queue. So what it does, first thing it does, it fewer requests are made. Okay, automatically if you are waiting, you will make less requests, right? Because in a few requests only you will get the message. The main aim is to get the message. So no multiple requests are getting wasted. So if few requests will be there, cost will also be less, right?
Okay. Fewer requests and the cost will be less, right?
Decreases. Like in short pulling, it was increasing because there are continuous requests being sent. So as number of requests will increase, like number of requests will increase. Cost of your billing cost will also increase.
Will also increase.
Number of requests
Okay.
less, then cost will be less automatically. This is short
Mm.
pulling. This is long pulling. Getting it?
Okay. Got it. People prefer that because I mean it's cheap.
Yeah, depending on the application you want to work, you can choose, right? Like now, what you can do now in long pulling, what it does, it eliminates. One better thing about one advantage of this is it eliminating false, empty responses by querying all the servers. Okay. See, there is a server and it is making a request query to the query, right? It's making a request. And unfortunately, they didn't send any message. So what it will tell to the server that there is no message in the queue. Like similarly, another time it will say there's a message. Another time they will say they don't have any message. They don't have any message. They have message. So what is the benefit of long pulling? It eliminates. It automatically eliminates these requests where they are saying there is no message because they are not useful to us. The useful ones are these that they have detected any message, because if they have detected any message by the server, that message will we have to send to the S3. So the request saying that there is no message in the queue, we will say we will going to eliminate in the case of long pulling. But in the case of short pulling, it was no elimination portion was there. All the requests were considered.
Mm. Can you give me another sample?
Yeah.
I want to understand the process of elimination on pulling.
See, there is a server. This is a queue. Okay. So say first request, this message has sent and it waited for 3 seconds. Right? And they didn't send any message. The queue is empty. So what response they will send? That queue is empty, no messages there in the queue. Right?
Okay.
Another time they have sent the request. Until then the message was there. They have taken this message and told the server that there is a message in the queue. And this message after sensing, they have sent this similar message to S3. Okay, so from here this message will disappear automatically because it is sent to S3. In the previous class I told you, once the server sends the message, once the server this message, it will automatically disappear so that another will not be able to see it. This is known as the
visibility time.
Yeah. Okay, similarly, then again they have sent the request and the queue is empty now. No message is there in the queue. So it will say there is no message in the queue. Right?
Okay.
Another time they send the request and till then message 2 has already arrived in the queue. So they will say there's a message in the queue. So this M2 message is there. Now what happens? This M2 message will go in the S3 bucket and from here it will disappear. Similarly, the process will go on. Like there's a message, there's not a message. Like multiple cases will be there. Right? So what long pulling does, it says, I am only interested in those requests where I receive the message. Because they are important to me. Else, I'll eliminate. They are not important to me. Then why should I keep them? Right? So,
okay, got it.
Doing with every server, this was server 1, server 2, and server 3. For every server, they will eliminate the requests which are not sensing the messages, and they will only take the requests which are sensing the message. So this process is known as where we eliminate false empty responses. These responses are known as false empty responses. So we will eliminate them in long pulling.
Okay,
Getting it?
got it.
So in this way, what happens? This wait time helps a lot. Let me just make you understand from clear one. In this condition, wait time plays an important role because the more the wait time is,
Mhm.
the more messages can come here and less will be the empty, false messages, or you can say responses, right? Getting it? Like
Empty full
waiting time is
responses.
more messages can come and the server will detect, and every time they will get a correct, they will send a message. So automatically the empty false messages which are not receiving any message, they will decrease. Hence, long pooling decreases the cost because requests will be less, right?
Okay, got it.
Uh, See, one more concept. If you are waiting for a message to be available in the queue before, see, it can sense both sending of message and receiving of the message. Okay, so it will wait.
Mhm.
Say like for 20 seconds, it's waiting. Okay, in the liver pooling, it is waiting for the 20-second inside a queue so that they have sent the request. Now it will wait for 20 seconds to check if there any message there, and they are receiving sending the response to it to the server again, right? In this case, what happens, there will be multiple messages to be occurred. Okay, till see, if you understand it, this is an empty queue, right? No messages inside this queue, and the
Mhm.
server is continuously monitoring it, right? It has sent the request to check is there any message. But if waiting time extends more than 20 seconds, then it will send you an empty response.
Empty response.
Or you can say connection timeout, it is known as. Now server will not be able to connect with the queue more than 20 seconds. As soon as 20 seconds are over, they will say there is no message in the queue.
Mm.
Getting?
Okay.
Is everything making you sense?
Yeah, it makes sense. And if they have a message,
Yes.
if I find a message in the queue, then I will get a response of empty false.
See, empty false message you will get when the server has sent the request to the queue and queue is empty, no message they have. So in response, it will say that I received a empty false response. There is no message
Okay.
inside the queue.
Okay, got it. Thank you.
Yeah.
Uh-huh.
Now next point about long pooling is that if you receive a message, okay, from the server, you are sending a message to queue, right? The wait time should be non-zero. So minimum is always more than 0, right? And the maximum time for waiting is 20 seconds. This I have told you very much clearly, like how how you can set the timing.
Okay, perfect.
Now, when we talk about short pulling and long pulling, billing is same for both. Billing is same means depending on the request. If short pulling makes X request and long pulling will also make the X request, then the billing will be same. Okay, because both are making same request, same number
Okay,
of
got it.
requests.
Same number of requests, the same billing.
Yeah, but if you're short pulling, because short pulling is famous for making more requests than long pulling, that's why it is said that short pulling cost high.
Okay, got it.
So short pulling and long pulling is very much clear now.
Mm-hmm. Clear.
Yeah, let's move to the next topic. That is SQS retention period. Now, what is retention period in SQS? So, see, SQS message can remain in the queue for up to 14 days. Okay, so this is a queue, right? And we received, say, message 1. So the time this message can remain in this SQS queue is known as the retention time. Getting it? What is retention time?
Okay.
The time this message can
Remain in the queue.
remain in this SQS queue is known as the retention time. The minimum retention time that a message can live in the SQS is 1 minute. The minimum is 1 minute and maximum is 14 days. Getting it?
14 days. Okay, got it.
And default you can say default that Amazon people has already set is 4 days. You can change it, but if you're not setting anything, then the message will remain for 4 days in the queue. Getting it?
Got it.
So once what happened? Once the retention time, or you can say retention period, is over for a message, it will automatically delete. Okay? Getting it?
Yes.
It will automatically delete.
The
Then
retention period.
another thing is that you can send the message like this user is sending the message and server is receiving the message. This process of sending a message and receiving a message can be done simultaneously. That the message is coming in SQNS queue and the message is going from the SQNS queue can be done simultaneously.
Okay.
Getting it?
Yes.
Now, where the main concept comes in, where SQS queue is mostly used. So, maybe you are familiar with these terms. Dynamo DB.
DynamoDB, yeah.
EC2 it is
S3.
used.
Oh, okay, EC2.
ECS it is used. Redshift it is used. Relational database management system it is used. In Lambda it is used. And in S3 bucket it is used. Mainly these are the Amazon services where SQ is used with. You can use SQ with all of these. Getting it?
Okay, got it.
Basically, it goes in combination. Say like today I give you the example of SQS with Lambda. Okay, I'll give you this example today. So
Okay, got it.
we use two services together. Usually, it is used for making distributed, or you can say decoupled applications. Okay, this is an application of SNS like SQS that where it is used in distributed
Got it.
applications,
Okay,
right?
cool.
Now, one thing you have that this is number one Q1, this is Q2, this is Q3, and this is Q4. So this is first SQSQ, this is second SQSQ, this is third SQSQ, and this is the fourth SQSQ. So you can choose the priority also. Like you can say this queue will that from all the servers first of all will check this queue. If all the messages are satisfied from this queue, then they will go to this queue and check the message. After that, they will go to this queue for checking the message. And after that, they can go to this queue. So, when we talk about multiple queue system, where there are multiple queues, because there are multiple queues, okay, you can set the priority. Which queue will be dealt first? Getting it?
Okay.
Clear?
Yep.
Now, another thing is that we'll go in detail today. We have discussed this before also. So it is SQS visibility time. Okay. So I'm writing all the theoretical part also. It is the duration. I've explained you earlier, okay? But just read what I'm writing. And if you feel any query, just let me know. So it is a duration of time. A message is logged for read by other servers, right?
Okay.
So I've explained this to you that whenever there is a server 1, server 2 and server 3, right? This is the queue they are reading. This is the SQS queue they are reading. And in that, there is one message. Now say all of them are sending request to this queue. But this message 1, was first sent by this server 2. Okay. So now we have to lock it. This is not known as locking. We have to lock it for locking for some time. Say and that locking for some time so that server 3 and server 1 will not be able to see this message. This locking time of a message is known as visibility time.
That comes when the second server like see the message, but now there is a locking time. So S3 and server 3 and server 1 cannot see the message during
Yes.
that locking time because server 2
Has
see.
already sends it and it is processing it.
Oh, okay, got it. Yeah,
So
that makes sense. Mhm.
maximum time that you can lock a message is 12 hours and default time is 30 seconds. Okay.
Okay,
See now
12 hours.
that say the locking time you have set is for 5 seconds. Means visibility time you have set for 5 seconds. But this server is taking more time to process this message. So what it can do, it can go to the visibility time setting and increase the visibility time also. Getting it?
Mm-hmm. Yes.
This much is clear, right?
Yeah, that's clear.
Okay. So now there occurs two cases. Like all of them are sensing the queue, right? And say again S2 was able to detect the message. And visibility time we have already set to 5 seconds. So for 5 seconds it is logged.
It is locked. Mm-hmm.
Now there after a message is read,
Okay.
there is two possibilities, right? There are two possibilities. What are the two possibilities? That when you acknowledge that this message is received by S2, this message is received by S2, so it must be detected from the queue to avoid duplicacy. So if we will lock it, okay, automatically no duplicate message can be created, right? Because only S2 is having this message, because as soon as it is detected by S2, they have logged it. So no duplicacy can be done. Okay, getting it?
Mm-hmm. I got it. During the locking time, no duplicacy can happen.
Yeah, because it is already logged.
It is locked. Yeah, it makes sense.
Now, one condition arises that say this is sensed by S2, but it is not able to process it. So what happens when it is and process was not able to happen for message one and visibility time also expired. So what happens? This locks open. Okay, this locks
Mm-hmm.
open, and now any other server, say S1 or S3, can detect this message. So say S1 has detected this message. Then again we have to set the visibility time and it is logged for S2 and S3. So now S1 will process the same message. So this situation can go for 3 times. Like if 3 times a message was not able to get processed by any of the server, then this will go into a dead box. It is known as a dead box. Okay, where if a message is unsuccessful in processing for 3 times, it will go in the dead box, and there they will check why this message is getting failed again and again. Okay, so first step first was that S2 has detected it, but it was not able to process it. So the lock was open, then S1 has detected it, and it was again not able to process this message. Then the lock was again open. Then they have sent it to S3. right? Then again, not able to process it, then they will send it to the dead box where they will check why this message is not able to process. What is the internal problem? What is the issue with the message and everything?
Okay, got it.
This is known as dead letter queue. Means it is for all the dead messages that has occurred. Getting it?
Okay, the process that you explained. Can you give me another sample of dead
Again,
letter queue?
you want me to explain it again?
Oh, the whole process
Which process?
is the dead letter queue. I mean, the all the things that you did.
Yeah, see, if the message, a single message, okay, this is a single message M1, if
Uh-huh.
it fails 3 times, that three times it has gone to any server and it failed in processing. It was not able to send it to the S3 bucket, say, for example. Then what this SQS will do? It will send this to the dead letter queue box. Okay,
Okay.
where all the professionals or the people who are sending the messages, they will check why there is a problem in what is the problem in the message, why they are not able to send it. Then they will fix this message, this problem, and then again after fixing everything, they will again send it to SQS. Getting it?
Okay, got it. So
Uh,
they get it from the dead letter queue to
yeah,
fix it.
I'll tell you what is dead letter queue later. Like completely, I'll explain you the whole process. What is dead letter queue? But till now, you are able to understand why what is
Oh, yes.
is working
Uh-huh.
on. Visibility time is clear, right?
Yeah, it's clear.
Then we after visibility time, you need to understand delivery time. So when we talk about AWS SQS, it provides us
Delivery time.
a delivery delay option. Okay, so that to postpone the delivery of the new message in the queue. So just try to understand it. See, this is a queue we are having. SQS queue we have. Okay. Say this message one we have sent by the user to SQS queue. Now the user also have the message 2 also, which they want to send it to SQS queue. But here they can delay this message. Like I want to delay this message so that first this message get completely processed and then I want to send this message to the SQS queue. Here the time taken to delay this message, like how much delay you want to provide, is known as delay delivery time. Getting it?
Okay.
So
Delay.
if you want to easily define what is delivery delay time for a queue, any message will not be able to visible to the server. This server, see there is a server, okay, they will only till this message 2 is not gone to this SQS because there is a delay delivery time we have applied. So this server will only be able to see the message 1 until the process, like any all the processes that needs to be done on message 1 is not complete. We will not send the message 2. Getting it?
Okay.
Okay, so
Yes, bro.
minimum time that you can delay a message, okay, is 0 second, and the maximum time you can delay a message is 15 minutes. Means no server, here are multiple servers, will not be able to see this message to for the time you have set. And the time you will set is known as delivery time, delivery delay time. Say you have set it to 5 seconds. So for 5 seconds, and no server will be able to see the message 2, they will only be able to see the message 1. They will never be able to see this message 2.
Mm. Okay.
So you can say,
That's the delivery time that the server can see the message.
yeah, like it's like simply like if you are standing outside a window, you are standing, and there is a process going on, like it's a doctor's clinic. It's like simple example I'm giving you, like it's a doctor's
Mhm.
clinic in which only one patient can go at a time, right? So all those other patients have to wait for the time their number doesn't allow it. Like it's written like only first patient can go in. So say this is the server. So they will only be able to process the first one until its process is not complete. No other patient or no other message can go inside. So the time they are stopping other patients to go in, or the time taken by the server to see other patients or other messages, this time is known as delivery delay time. Getting it? Because
Okay.
in some cases what happens, that you want first process to be completely done, then only the second process can be done. There are multiple cases you can assume, like if you want to, like, from which field you are, like it will be very much easy for me to give you examples.
Mhm. I mean, it's I like it. I like it because I mean, it's like understanding in a different perspective, and you know, you got the gift
No,
to
actually, if
translate
you,
AWS to real situation in life or real examples like everyday something.
like I was just about to give you an example of baking a cake. So I felt like if you, I give you an example that is very much related to your field, if you're able to describe like what studies you have done or what is your past experience, so I'll be able to connect with you in a more better way, like with the example.
So, like for example, I used to do like triathlons. Triathlon is like swimming, biking, and running. So I used to do those three in one
You are an athlete.
competition. Yeah, an athlete, and I like to run. Um, I have friends. I like to play games like dominoes. I like Monopoly, chess. What else? Let me,
Like any like I'm asking what is your academic background, like what you're doing currently and what was your previous academic.
oh, business administration. So I mean, in college, I'm doing business administration right now.
Okay, business
Um,
administration
doing
bachelor's.
no, like a doctorate,
Okay.
but it's like I mean the process and doing business administration, concentration in finances and IT.
Okay, like business, you are studies of business, right?
Yeah, like business that involves marketing, management, organizational leadership, like you know how to like building a company, getting employees. What else? Yeah, something. You know, when I was doing my master, I was into the stock market. So I used to just to analyze the stocks and choose the best stock to to invest.
So may I know what's your age? Because
My
your age
age is 30.
30. Right. That's
I'm
why you're doing multiple things.
uh,
See an example for you.
yeah, it's not easy.
Yeah. See, you are an example, like you said, you're an athlete. So, see, you must have gone to a relay. In relay, there are four people,
Okay.
team, right? So, there are four people standing at like 100 meter distance. This is 100 meter, 100 meter, 100 meter, and this is next 100 meter, and this is the finish line. So, till this person will not finish this 100 meter, this person has to wait, right? Till this person is not finishing this task, complete task, this person has to wait. Then only this person will able to take the baton and go to this next process, right? So
Okay.
what is the process of this person is getting delayed because of this person. So you can understand the time taken for this person
Hmm.
is waiting for the person to complete this process. In such scenario where all the processes are interconnected, like one process has to complete, then second process, then third process, and then fourth process. And at a particular time, only one process is activated. Others are at rest. Right? So in such cases, delivery time comes in. Delivery delay because the process of this person is delayed, and because of these two. Just a minute.
It's gone.
Yeah, just a minute. Okay. So the time this person is waiting is known as delay delivery time. Getting it?
Okay. Okay.
Now we can just
The
move
daily.
to another topic. This delivery time concept is clear, right?
Uh-huh.
Next,
Very clear.
next move to receive message wait time. See, while you're dealing with this Amazon SQS, you have to set all these times there. So if you're not very much clear, like what this time particularly doing, you're not able to set it correctly. Okay. So
Mm-hmm.
these that's why the understanding of theoretical part is very much important here. So see, default time is 0 second, and this is the short pooling. Receive message wait time means the time in which this server is receiving the message from the queue is known as receive message wait time. So if it is going faster without any waste, then automatically it is short pooling, right?
Uh-huh. Yes.
And the more time it will take, like more than 0 seconds, right? Then it will be long pooling.
Long pooling. Okay.
Okay. So the maximum amount of time that a long pooling retrieve call will wait for a message become available before returning to the empty response. Like, see, if it is waiting for very long time, I told you, like it is waiting for in the long pooling concept, if server is waiting for very much long time to receive any message and the time expires to 20 seconds, then it will return the server an empty false request that there is no message in the queue. The maximum time is 20 seconds.
Got it.
Clear?
Clear.
Yeah. Now let's move to dead letter queue. I told you what it is. Now I'll explain you in depth what is going on. So the main task or the main concept of dead letter queue is it handle message failure. Any message fails for more than 3 times. So it is handled by dead letter queue. So what it says, it lets you set aside and isolate messages that can't be processed, right, correctly.
So yeah, nice. My messages that cannot be processed correctly.
To determine
Failure.
processing didn't succeed. Okay, so what it helps you, you can just read it, that it lets you set aside, isolate the messages that are not processed correctly, means the failure messages. You can put them aside and determine why their processing didn't succeed and determine what problem they are facing while getting processed.
Okay.
So
It's like what is called like you can inspect or you can I was talking about I was thinking about a cloud trail. I mean I know this is like a different topic, but I was thinking about like cloud trail that you can inspect uh, what happens, you know,
like I'll give you a simple
like an
example.
inspection. Yeah. It's
There are students in a class.
mhm. You got it.
Students, and there is an exam. So some student passed, some student failed. So now what we are doing, if a student is failing more than 3 times in a subject, they will take those students and isolate them in another class. Okay, and they will check why the single student is facing what the problem they are facing. Either they are not able to understand the subject, either they are not able to learn them properly, what problem they are facing. And once the student is very much good enough to all the problems they have solved, then they will again send them for the exam, and the exam in our case it will be in the SQS queue, and then they will again detect these messages again and check if it is processing again or not.
Okay, got it. You
It's
know, that's better. That's better than my example of what I was trying to say.
yeah. So what happens? We don't use a dead letter Q, okay, with FIFO. Okay, we never use dead letter Q with FIFO Q.
Okay,
So,
good to know.
because if you don't want to break the exact order of the message or operation, because in this what happens in FIFO, it is we already know that first in first out. So it is the first one. So it will be get processed first, right?
Mhm.
Say first, second, third message, and fourth message. So we know it will be processed first, right? So say this get failed. While processing
Okay.
it failed, but this gets passed. This also get passed. This also get passed. So what will happen after reprocessing it in the dead queue? It has to go right back to this order, M4 order. So the order of the FIFO, order of the messages changed. So now the order become M2, M3, M4 and M1. Because it was failed earlier, so now it has to be processed in the last. So that's why in FIFO we don't allow it to use dead letter Q.
Okay.
Okay, that so it's all about SQS. Every theoretical concept is completed. Now let's move to the practical portion. So you also
Oh,
must be having your AWS account.
yes, yes. Can you give me 2 minutes?
Yeah, sure. Take your time.
I'm back.
Yeah, so you can see it.
Yes, I can see it.
That this is the Amazon management.
Management of.
So you
Mhm.
have to start with services. In
Okay.
services, you have to go down, right? And in the application integration, you will find simply queue service,
Okay.
right? This is the SQS service I'm talking about. Then
Mhm.
you can just read it. Amazon Simply Queue service is reliable, scalable, fully managed message queuing service. We have already discussed this, right? We have to now start it. So we'll just click on start. Now see, you have to give a queue name here. So just write any of the queue name, like I've implemented it. So I've taken this queue name as test queue, right? And the data center I'm taking is Mumbai. You can take it
Okay.
or one. And there are two types of different queues like standard queue and FIFO queue. We have already discussed. So here I am taking standard queue, right, to deal with.
Got it.
Getting it?
Uh-huh.
Now it is just explaining everything what is inside FIFO and what is inside standard queue, and we have already discussed about it. Similar thing they are telling us, like exact processing speed, throughput, at least one delivery at once, best effort ordering, and all these 6 we have already discussed. Okay, now if you will see, it is quick create. If you start directly on quick create, you will not be able to see what is going in background. So first of all, it is better to go on configuration queue option, because if you will go on directly quick create, you will not be able to understand anything, like it will directly create a queue for you. But if you will go for configure queue, see, now you are able to set multiple options here. See, I have told you default visibility timeout, and the it is starting from 0 minimum. It is minimum is 0 and maximum is 12 hours. Getting it?
Yes.
I'll just stop this here. Okay.
12 hours.
So what it is telling us here, default visibility time. Okay. So you can either keep it as 0 or you can keep it as 12 hours, the visibility time of the message. Right? I told you this. Then this is
Yes.
message retention period, for how much time message will be viewed in the queue, right? In the queue, if you want to keep a message, for how many hours or time it will be there. Default, I told you, for 4 hours the message will be there in the queue. Minimum is 1 minute and maximum 14 minutes. Maximum message size, maximum how many messages you can keep. You can keep, I told you, 256 KB of messages. From one message to 256 KB of messages you can keep in your queue, right? Delay, I told you, for how many for messages you can put the delivery delay, like after one message is visible to the server. Now second message also, you want how much delivery time you can apply for this particular message, so that the server is not able to see and only process the first message. So this is the delivery time, delivery delay, 0 seconds and 15 seconds, 15 till 15 minutes. Then receive message wait, right? This is nothing but short pooling and long pooling. Receive message wait time, like this server is waiting for this queue to send the message. So either it can be done quickly or you can say immediately, like we do in short pooling. Otherwise we can set a wait time. So here, if you will put this value of 0 of receive message wait time as 0, then it will be short pooling. And if you will increase it, the maximum I told you, it is 20 seconds. Like for 20 seconds, if a server is not getting any response from the queue, then it will return after 20 seconds and the connection will, this is known as connection expires. Right? This is, if you keep it at 0, it will be short pooling, and more than 0 if you keep, it will be long pooling.
Got it.
This much is clear. So I'm just setting it all together. So this is the visibility time I've set, like visibility time I'm setting as 30. Right? You can put the visibility time according to your preference. Right? How much time you want to give to a particular message so that it can be visible to a server. Like you can change it to any value, like 40. Then if you talk about message retention time, the default one is 4, but you can adjust according to it, like for how many for what time you want to keep this message in the queue, depending upon you. Then I have told you about maximum message size, right? Then the delivery time and the receive time. You can see, if you are very much clear with the theoretical concepts about these options, only then it will be beneficial for you
Okay.
for any of the process you are applying, because you have to design a system for messaging. If this hi message you are sending to a person, wait just a minute. If you are sending this hi message to a person, okay, and if you set its delay time as 2 seconds, right? And this is your say this is your name, okay, and here delay time is 0. So what will happen? Your name will go first, and then after 2 seconds, hi will be there. So this will be inappropriate. Obviously, the message you want to send it first was being late, sent are received by late. So such type of application require very much quite understanding how and where you have to set these requirement files. Okay, these are the requirements for any of the process to happen. Now you can set all these default values, right? So they already have been default set by the Amazon people. But if you want to change it to according to your application, you can fix them, right? Now another thing comes in this.
I have a I have a question.
Yeah, just a minute. Yes.
Okay. Okay. Now. I mean, I'm clear. Yeah.
Yeah.
It was about the message side.
Yeah, it depends on your preference, like how you want to design your application.
Okay. Got it.
So this is now the another concept is about delay letter queue. See, according to Amazon people, they have not set any delay letter queue enable system. But if you want, you can enable it from here. But for now, I'm not using it because we are creating a very much simple process. But if you want a dead letter queue to manage all your failure messages, you can apply. Now you can apply server side encryption, means you can apply passwords by allowing this message, and they will give you multiple keys and everything. Okay, it's up to your requirement if you want to set the server side encryption. Means no messages from your server can be checked by anyone else. So these are basic requirements you can apply. See, now directly you can just create the queue, all the things you have done. So now you can see we have a test queue we have recently built, and there is no messages still yet because we have not sent any message. And message flight means that you don't have any failure message. This is for failure message, and this is for received message, any message you have received. So let's try sending the message and check how in SQS we can send and receive the message.
Okay.
Right. So you can see the type of queue is standard queue we have taken. Of that, you can take the FIFO queue also. That's clear. And you can check all the details here regarding your queue.
Perfect.
This is the name of the queue. This is the type of the queue. Content based, no content we have recently applied. No message we have sent. No failure message we have. Here the details about this SQ can be seen. Permissions can be seen. Now you have to enable Lambda trigger. I told you that what we are doing, we are making a process where we will integrate SQS with Lambda. Okay. So we have to enable the Lambda part portion. I think you have given me in the content you have asked me to explain you the Lambda also, right? So we will go for the Lambda after SQS, SNS. Hello.
Hello. Yes, I'm here.
Yeah, is there any connection problem?
No.
Okay. Okay. So we have to see, now we have created a queue, SQS queue we have created. Now we will
Mhm.
add a lambda trigger to it. So for adding lambda triggers, we will follow a process. See how we'll create it. So we have to create a lambda trigger for you, so that we can just connect our message. We will send our messages from lambda and it will be stored in the queue. So for queuing actions, we will first send the queue. Okay, just
Okay.
clear it. So you can create a message body here, message attributes you have. So say you are creating a message, say process one message or process MP4 message you can create. You can type any message you want to type and send it to the queue. Right now, here in message attributes, you will see all the metadata. Right,
Okay, got it.
you will check. You can name the message. You can provide what type of message you want to send. What you can add multiple attributes also. Depending on your choice, you can fill this metadata. But it is empty, so let it be empty. No issue with that. Okay, so just if you want to add more attributes, provide names to this attribute, you can easily apply it. Okay, so now getting back to the message, we have created a message. You can write it. Now here for a single message also you can apply delivery delay time. That if you want for a particular message, this is message one, right? You want to make it,
Uh-huh.
you can easily fix the time here by clicking checking this box.
Okay.
It.
Got it.
Now, if you want to do it, either do it or let it be, then you can just send the message. So I'm just clicking on sending the message. So as soon you send a message, now you will see that here from 0, it has changed to 1. So one message we have already seen. From the action queue, you can see if you want to send another message, similarly you can do. You can create a message body of your type, like anything you can type, so that you want to send inside a message, like publish video. You're saying delivery time you can apply if you want, and just simply click on send message and it will send a message for you. It is that simple. So now you have two messages. Getting it?
Okay, got it. Missing a
Now
little
there
bit.
is no message failure, that's why it's 0 here. Now inside our queue we have two messages. Getting it? In
Uh-huh.
our queue, this is our queue. This is our
Okay.
test queue. Inside this queue, we have message 1 and message 2 now. Getting it? Now
Yes.
we have to send them to the server, right? And the server that we are taking will be a Lambda server.
Lambda. Okay.
Now let's see how to create it. So after creation of this is standard queue again, two messages, no message failure yet. Okay, and the name of the test queue is this queue. Now the greater part is Lambda trigger. So what Lambda function configure this account? You have to incoming message to trigger one more Lambda functions. So now we have two incoming messages, right?
Yes.
So now we have to design a Lambda function for them. So then again, we will go to the services. Inside that, inside compute, we have this Lambda function. Then you will see AWS Lambda function. Here you will go and create the Lambda function. So for creating a this is the basic default one. You can easily choose. Why we choosing this one? Because it provides sample code. So multiple sample codes they provide you so that you can easily work on them, right? Because we are just using Lambda for sending and receiving messages, no more use. So you can just, if we have selected this default one, you can just create a blueprint name. Any name you can provide for the blueprint. Like we are dealing with SQS, so we have created a name of keyword SQS. Now you will see SQS puller mess trigger has been created. So this is the SQS puller trigger by Lambda function that has been created with us. Simple to implement Lambda. This is the minimized functions that we are understanding about Lambda. Because for our session, we don't require Lambda that much. We are just using Lambda for triggering the two messages. So till now, what Lambda has done to us, we have created a Lambda file, right? On just going to the create Lambda button. Then we have selected a basic default trigger, that is blueprint trigger. Okay, inside that blueprint, because we have to deal with SQS services, that's why we have created an SQS blueprint, and that the blueprint that is being created is SQS pulling trigger. This much is clear?
Yes. Lambda blueprint.
Now we have to give some names. We have to configure this. So I'm just explaining you how you can configure. So configuring, you have to give some name to this. So we are using Lambda function for SQS.
Okay.
Just give a name, like you can give any name you want. Then
what was the blue? Well, I have a question.
Just a minute.
What was the blueprint that you choose?
Which one?
The previous when you was creating, or when you were choosing the blueprint.
Yeah. This one.
Oh, SQS. Okay, you put SQS.
Because we are using Lambda for SQS. That's why it is giving us we have to choose the blueprint type as SQS. Getting it?
SQS puller. Okay, got it.
Now we have to configure it. So we will provide some information inside it.
Perfect.
So you can provide any function name to the trigger. So this is a trigger, Lambda trigger we are using, and you have to provide it name. So we have to create a new role. That's why we will create a new role in it for the Lambda process, because no previous role we have created yet. So for SQS, we are creating a new role. That's why we are selecting this option. Okay, role name you can provide any role that you want to play. So say my role name you have given. Then see what policy template they are using. They are using SQS Polar, because in blueprint we have shown that we are using SQS Polar. So you have to just select it. By default it is selected by Amazon people, but you can just check it, recheck it. In your system it is automatically selected if you have selected the blueprint one. Then what SQS you want to search on, what SQS trigger you want to put, like you can have multiple queues like Q1, Q2, Q2, right? Multiple queues you can on which one you want to apply this trigger. So say our queue name was test queue, so we want to apply it on test queue.
Okay.
Select the name of the queue on which we have to apply this trigger. So it will provide the complete ARN for us for our queue, right? Batch size, like you can decrease the batch. It's the maximum number. See, messages are retrieved in the batch form. Like one batch contains, if you select the bunch, so like I'm selecting 5. So there in a single bunch, there will be 5 messages. 1, 2, 3.
Oh, okay, okay.
Now you
As,
have to simply enable
mhm.
this trigger. So it will, as soon as you will receive send a message, this trigger will sense it. Now you are creating this function. So as soon as you send the message using the SQS, in the SQS they will sense a message. They will automatically enable the trigger for you. Getting it?
Okay, got it.
So now see, congratulations, your Lambda function has been created for test queue. So test event and test functions. So this message is very much important if everything is going fine with your system.
Okay, I got the same message.
Getting it?
Uh-huh. Yep, I got
So
the
now
same message.
now let's check. See, this is the Lambda for queue we have created. It is created, and we are using it for SQS. It is showing the complete design of the Lambda function.
Yep.
Now, see this test queue. It is showing which on which SQS we have applied it. So it is taking time because it is taking time to get created. Let me just. So it will create in the time it is taking. So it's creating. Let me just refresh it. So our Lambda function test queue is created and now it's enabled. So this enable function is very much important. It should show you that this is enabled. Okay. And if
Okay,
it,
let me
they
see.
will ask you for the
Enable.
saved function.
Okay, got it.
Either enable or you have to apply the save function. Then your Lambda is ready for your test queue.
Okay, I got it.
Getting it?
Mm-hmm. Yes.
If it is disabled, you have to save it. Otherwise, usually it is enabled.
Okay.
Now, once it is created, we can check the ARN they are using. So now in services, you can go and check the simple queue service. SQS you have taken. Again, you can see there is 0 messages now. Because what happened? Just a minute. So what happened?
Let me.
Earlier there were 2 messages. Earlier there were 2 messages here, available messages. Now it is.
Let me. I'm gonna check it out now.
You can check what?
I'm gonna check. I'm gonna check if I have the same. If I have 0 messages. Okay, I have 0 messages.
Getting it?
In my SQS, I have 0 message.
Now in the SQS, there will be 0 message because I have connected with the Lambda function. Right? They have sent the 2 messages and send it to the server. As soon as there is a message now, it will be sent to the server using.
Okay, so that's okay. Got it.
Now you can check multiple things like how it is happening by just going into the depth of this test queue. See, so permission and monitoring, you can check how it is working. So you can see there are multiple graphs given. So first number is message, number of messages sent. How many messages are sent to the Lambda queue? So here you can check there are 2 messages that has been sent from the test queue. Yes, we have sent 2 messages. We have created 2 messages, right? So it is showing that we have sent the 2 messages. Now, if you will check for the received one, this is the received one. So you can see you have received 2 messages. Getting it?
Okay.
This is the
Yes.
they are telling the count, like how many messages are sent and how many messages are received. And the Lambda trigger that you are using is this one.
Okay, got it. So I can
Getting it?
see, yes. How how do I,
Is it clear?
yeah, it's clear. I just want
Now
to,
you have to delete everything. Delete the queue, otherwise it will start charging. So delete the queue,
okay,
and then you have to delete the lambda function also. So go in services, history, lambda function you have created, select it, and in the actions go and just delete. So remember all the services that you are using, delete them after the use. Otherwise they will start charging. So lambda function is getting deleted. That much is clear now?
yep, clear. Let me delete the lambda functions. Okay, zeros, is zero queues, zero lambda. Okay, got it. All deleted.
Everything is clear? You
Yep,
in your system also?
yeah, it was clear. I got it. In my first time using lambda and SQS.
Yeah, so is it everything is clear now? Like any doubt you have?
No, I don't have any doubt. Um, I just gonna keep watching this video recording, and it
Yeah,
will be
just go through
fine.
the recording once again and try to
Mhm.
implement it on your system until again you find any queries or any issues regarding the implementation. Please let me know, okay, in the next class.
Yep. So the next class is gonna be about
SNS.
SNS.
Yeah.
Yes.
So in the next class, we'll start SNS and hopefully tomorrow or by tomorrow, we'll finish it. SNS.
Okay. Perfect. Because it's easier, right? SNS is easier than
If you,
SQS.
yeah, if you're able to understand this easily, then it will, it depends on the content. Sometimes some topics are longer, some are short and easy to understand. So it depends on how it is going. So let's see
Oh, okay.
in the next class. Till then, you just revise everything and please bring the problems in the next class, right?
Got it. Okay.
Okay, good night.
Thank you. Thank you. Good
Thank
night.
you.